Okay, so this is going to be the first lesson of our next unit. We're going to be taking a look at square root functions. We've finished everything with quadratic functions. You'll still need to be able to factor and solve quadratic equations, but we're moving on from quadratics. Okay, so a square root function. As its name would apply, a square root function is a function that has a square root in it, right? And here's an example of a square root function. So we have f of x equals square root of x minus 2, which is just like y equals square root x minus 2. Okay, so if we start filling in the table, I'm going to start with 102. So if x is 102, y, or f of x, is square root of 102 minus 2, which is square root of 100, which of course is 10, right? For 11, y equals square root of 11 minus 2, which is square root of 9, which is 3. For 2, y equals square root of 2 minus 2, which is square root of 0, which is 0. Oh, for negative 7, watch what happens. So y equals square root of negative 7 minus 2, which is square root of negative 9, which is 3i, right? We know that's not a real number. So in the set of real numbers, this is not going to, we're not going to use 3i. We're just going to write not a real number, okay? And this gets into the issue of square root functions have what's called a restricted domain, okay? So in order to get a real number, so the inside of square root, which you should remember is called the radicand, must be greater than or equal to 0, okay? Because we know the square root of 0 is 0, we know square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, etc. But anything where the square root is negative is going to give us a it's going to give us an imaginary number, okay, and something to do with I. All right. So fill in the table using the square root rule. Okay, so we have a different function here, f of x, or y equals square root of x, and notice the 5 is outside of the radical. So this would be y equals square root negative 1 minus 5, but that's I minus 5, which is not a real number, okay? So for 0, y equals square root 0 minus 5, which is 0 minus 5, which is negative 5. For 4, y equals square root 4 minus 5, which is 2 minus 5, which is negative 3. And for 9, y equals square root 9 minus 5, which is 3 minus 5, which is negative 2. Okay. So, graphing a square root function. So we need to determine the domain first, because we're only going to use the values that input into the square root function and give us out a real number. So like we were saying, with the restricted domain, we need to set the inside of the square root greater than or equal to 0. Okay? Then we'll plot several points, and the points must be within the domain. Let's take a look. All right, draw a little coordinate plane. All right, so first thing we need to do is we need to determine the domain here for number 3. So we have y equals square root 2x plus 4. We're going to set the inside of the square root greater than or equal to 0. So we're going to go 2x plus 4 greater than or equal to 0, subtract 4, 2x greater than or equal to negative 4, so that means x is greater than or equal to negative 2. Okay, which means our graph is going to begin at negative 2. All right, anything less than negative 2 is going to give us a imaginary number, right? If we put in negative 3, it'd be square root of negative 2, which is I square root 2. Okay, so let's make a little table, right? So we're going to go x, y equals square root 2x plus 4. So we'll begin with negative 2. Y equals square root of 2 times negative 2, negative 4 plus 4, square root of 0, which is 0. Okay, so that's going to be an intercept. If we do negative 1, y equals square root of negative 2 plus 4, square root of 2, which in the calculator, if we go to the calculator and get a decimal for that, just so we can get an approximate value, that is about 1.4. Right, then if we do 0, y equals square root of 2 times 0 plus 4, which is, of course, 2. All right, so let's put these on the graph. Okay, negative 1, we're about 1.4, so like there. At 0, we're at 2. At 1, y equals square root of 2 times 1 is 4, square root of 6, which is about 2.4. So about there. And let's do one more point. So y would be square root of 8, which is about 2.8. So we go really close to 3. And then let's finish with the 3. Y would be square root of 2 times 6. 3 times 2, 6, plus 4, square root of 10, which is about 3.2. All right, so we go a little above this. We're going to be like there. Okay, and then if we connect, all right, there's your graph. Okay, so it's almost like half of an inverted parabola. So that's what a square root function looks like. Okay, let's take a look at number 4, our domain. We want to set the inside of the square root, ignore the outside. X minus 3 must be greater than or equal to 0. That means x is greater than or equal to 3. So this graph is going to begin at 3. So I'm going to ignore the negatives here. Let's do a little table. All right, so at 3, we have square root of 0 plus 3, which is 0 plus 3, or 3. At 4, we're at square root of 1 plus 3, which is 1 plus 3, 4. At 5, we have square root 2 plus 3, and square root of 2 is about 1.4, so this is about 4.4. At 6, we have square root 3 plus 3, which is about 4.8. And then at 7, y is going to be square root of 4. Good, we have a perfect square, plus 2, which is 5. Okay, 2, 3, 7, 5. So your graph's going to look like that. Okay, last one, number 5. Y equals 2 times the square root of 2x plus 6 minus 1. Okay, we need to be careful in evaluating this. So again, the domain, we're going to take the inside. So that means x is greater than or equal to negative 3. So the graph will start at negative 3. Oops. Okay, make a table. All right, so at negative 3, y is going to be 2 times the square root of negative 6 plus 6 squared is 0, minus 1, which is 2 times 0, 0, minus 1, which is negative 1. Okay, so we have negative 3, and then negative 1. I'm going to skip ahead to negative 1. Y would be 2 times the square root of, you don't need to do like every consecutive point. It's going to be 2 times negative 1, negative 2, plus 6. We have the square root of 4, so good, we have a perfect square, minus 1. So we have 2 times the square root of 4, 2 times 2, 4 minus 1, so they're at 3. So we have negative 1, 3, right over here. And then I'm going to skip ahead to positive 1. So y would be 2 times the square root of 8 minus 1. So square root of 8, and then times 2, it's about 5.6, and then minus 1, so about 4.6. Like there. Let's do 2. Y equals 2 times the square root of 10 minus 1. It's about 5.3. And let's finish by doing 3. Y equals 2 square root 12 minus 1. Which is about 5.9. So we are just under 6, like there. Okay, so the graph is going to look like that.